Hi everybody, so we're back. Following up on the last video, we talked about dividing fractions and how we subtract when we divide. If you need a refresher on that, please see the last video right before this one. And today we're going to move into the third rule of exponents. So we talked about multiplying where we add them, dividing where we subtract them. And now we're going to talk about the what I call power to a power rule. So when we have an exponent raised to another exponent. So you can see I have some examples out here, and we're just going to run through some examples, and it should be pretty straightforward. We'll also refresh on the negative exponents. So you can see I already included one right here to refresh on how we make a negative exponent a positive. Okay, so let's get into it. This should be a real quick video. So here, instead of having where we had before, right, x to the third times x squared, right, that's when we add them, and this becomes x to the fifth. Now, a lot of people confuse these rules, so it's important to recognize the difference. So this is not that case. This is x to the third raised to the second power, so squared, right? So in this case, we actually multiply these powers. So we get x to the third times 2. So our answer should be x to the sixth, not x to the fifth. So this is a very important difference, right? And the reason that that is the case is because x to the third squared is the same thing as saying x to the third times x to the third, right? We're multiplying two of them. So then if we had this, we could say, okay, well, that's x to the third plus 3 plus 3, right? Which would give us x to the sixth, which is the same answer. But it is definitely not the same as x to the third times x squared, right? That is x to the fifth, which is not the same. So that's a very important distinction. So what I did right here is totally okay and totally allowed, and right, you can see it gives us the same answer. But I would recommend using the previous method, just multiplying the two exponents, A, because it's faster, and B, because when we have bigger numbers, that's not going to be as friendly of an approach to like write all of these out multiplied times each other and add them all. It's going to be much easier to just multiply those exponents. So here we have the second example, right? Y to the seventh times negative 3. So we get y to the negative 21st power, right? So now here's our refresher on what to do with that negative exponent. So if you remember from the last video, we said in order to make a negative exponent positive, all we have to do is move it to the denominator of the fraction. So here I would have 1 over y to the 21st power. And that's it. So remember, if we have a negative exponent, it has to go down to the denominator, and then it can be positive. In a case like this, where we didn't have a fraction, right? It was just y to the negative 21. That's why we have that 1 on top. So we can imagine y to the negative 21 is over 1, right? Any like whole term is over 1. It's just, I imagine, to be an invisible over 1, right? So when we want to make that exponent positive, we move it down to the bottom, and then we have 1 over y to the 21. All right, awesome. We'll just run through one example using multiple variables, and then that's it. All right, let's do an example. X to the third y squared z negative 3. That's not a great negative by me. Negative, let's make it negative 4. Okay, and all of this squared. Okay, so in this case, my squared has to go to the 3, to the 2, and to the negative 4, right? We have to use the distributive property here. So we get x to the third times 2, y squared times 2, and z to the negative 4 times 2. And from simplifying, we get x to the 6th, y to the 4th, and z to the negative 8th. Okay, one more step, right? Because we have a negative exponent. We simply have x to the 6th, y to the 4th. Those are positive. They're totally cool. And then we have to move that z to the 8th down to the bottom to become positive. And then we are done. And there is just one more rule I want to touch on, but I'm going to do it in the next video. So make sure to check the next video for more examples like this one. And we're also going to add in an additional rule with squaring terms. But just for a quick review, right, we talked about the power to a power rule today. And that is when we have an exponent raised to another exponent, we multiply them. All right, thanks, guys.